Welcome everyone to the next session. So let me set the context of this session, right? So the context is that I have been teaching machine learning, predictive modeling, call it AI now. I mean, it's much cooler to call it AI than machine learning, So one of the most common challenges is that people actually think and approach building a model as just, calling that one line of, code in R or Python, your scikit-learn and all of that, right? But the reality is that the machine learning models, when you build them, your predictive models, at the end of the day, I mean, there is this, think of this, you're building the model downstream somewhere, there are decisions being taken. And anything that happens in this whole chain, it impacts your business, right? So potentially, is the model maintainable? Is the model fair? Is there any bias? Can you go back and track what happened in certain release of the model? So the idea of MLOps is, well, machine learning operations, if I put it that way. So machine learning operations actually formalizes the whole engineering process, and I would say also puts the engineering in the context of business, right? So with that, I will ask our panelists. We have amazing folks. I mean, book authors here. I mean, two of you are book authors. I know two of you are startup founders as well. So you know much more than I do about MLOps. So I would go ahead and get started, and maybe all of you can introduce yourself a little bit. Give us a little bit about what do you do right now, and in general, what kind of problems you're handling. And then we'll take it from there. So Mehdi, do you want to go ahead and get started?
Yeah, sure, I can. So, Mehit, thank you for inviting me to this panel. So, I've been in this, working on data science models, ML models, AI models for the past 20 years. After my PhD, I worked in a series of startups where we were trying to build AI models that could be scaled. Then I joined Microsoft, and I was there in Azure Cloud, where I was building a network simulation tool, including an AI model that worked with it. And of course, as we scaled, and when I joined Azure, it was a 30 people team, and when I left, it was more than 15,000 people. We dealt with different levels of scale, and each time we had to re-architect every single component that we had built. And later, I joined Microsoft Research in autonomous AI, where I built an autonomous AI tool for deep reinforcement learning. And over there as well, we hit serious scaling challenges, and we had to redesign our entire stack. Um, After my last stint, I joined Amazon, and in Amazon, um, we have um, a very different kind of AI and ML challenges as well. And I'm hoping to with this panel we'll get to a chance to talk about like the different flavors of AI models and how those AI models bring their own challenges. And I think I'm hoping to learn from this panel as well. The solution that we have found and the ones that we are we still stumble upon.
Okay, thank you, Mehdi. Hamza, you want to go ahead?
Yeah, thank you, Raja, for inviting me on the panel as well. Yeah, so I've been working in machine learning as well for the last 7 years, and essentially working mostly in ML startups and facing a lot of these machine learning operationalization problems, especially as Mehdi said, as we scaled from small scale notebook setting where you're just sort of experimenting in R&D to getting it out in Kubernetes and getting the model scaled up to thousands of users. Specifically, like my last startup, so I'm doing one now. So I am co-founding a startup called ZenML, which is an open source MLOps framework. And a lot of that is sort of like scratching our own itch, because I faced those problems personally a few times, especially in the previous startup I was doing, which was around predictive maintenance at scale for trucks and buses and mobility assets, which is a quite a real world problem where you see a lot of physical assets drift the data in a way that is quite interesting, and to have systems on top to account for that loop and to impact the business value, as you said, Raja. is has been, I would say, quite a challenge. So taking from all those experiences, now for the last year and a half, we've been building ZenML, which is a framework that builds all these tools that are out there to sort of help build the MLOps pipeline and to bring them together. So I've been in that capacity. I've been working with a lot of tooling providers. I think I sort of know every like tooling provider, if not personally, but through integrations and working in the field, and also the cloud providers and their platforms. So it's been an interesting journey to see the MLOps landscape evolve from what was 4 years ago, basically nothing. We don't even have the word MLOps back then. And then it became like the hype cycle. And now it started to like normalize in the innovation curve, and it is like replaced by LLMs and foundational models now. But still, like believe that even the LLM and the foundational models are fueled essentially by systems that can have automated, repeatable, reproducible processes and pipelines behind them. So that's what I'm like sort of dealing with all day, and I'm very interested in this panel to learn more about how other people think about it, and perhaps contribute my 2 cents. So thank you for the invite.
Okay, thank you, Hamza and Natalia. Do you want to go ahead?
Yeah, sure. First, thanks for having me for this MLOps panel. I'm really excited to be in this very cool event. What I wanted to say is that this is an exciting moment for DevOps that also manage machine learning workloads. You know, this figure now is called the machine learning engineer, right? What I'm kind of representing here is how Red Hat envision this as a company fully open source, and how the open source tool are helping ML engineers to put in consistency across workloads, across environment. So what Red Hat is really doing is providing you what we call the open hybrid cloud. So the same approach, the same paradigm, it's valid for many platform. And in our case, the platform is OpenShift and Kubernetes. So we have a kind of a standard platform where our machine learning workloads runs. And what we're kind of doing in the community is defining a pattern, it's defining a reference architecture on how to do that. So my job is to be a developer advocate here in Red Hat. So I'm a developer advocate for Kubernetes, OpenShift, and all Red Hat technology. And I think our ultimate goal is to promote that into the community and into the industry. So thanks for having me today.
Thank you. Faisal, you want to go ahead?
Thank you very much. So the way I work is one of the challenges I see in the market is as Andrew put it, is a long tail problem. Is a lot of enterprises have the machine learning have the problems that could be solved by machine learning, but at the algorithm level, at the modeling level, they are kind of solved. But the problem comes on how we collect the data, how we make sure that we can run the models with lower cost, especially at the factory floors where the hardware is of less power and there's a lower chips available at the edge, and how we can make sure that those models are delivering consistent value with the business. I'll give you an example. I live in Australia, where we use public transport a lot. We have a public transport, and we have some apps run by Department of Public Transports that predicts how full your bus is. So there are two ways. One is by train, they have weight sensors and they tell you how full the train is, but bus, they don't have weight sensors, so they do by prediction. And what happened with the COVID is the government announced that there's a curfew from tomorrow and nobody can use the public transport bus. But when we opened the app, when the curfew has announced, there were like 2 people in the bus, but still the app is saying the bus is like 40% full or 50% full. So you can see here there was a drift in data and a different situation that was not adopted fast enough to continue to deliver value for citizens or users of the products. So much for me, the machine learning operations is about bringing all the realities of the real world, keeping cost in the picture, and seeing that the model that we build is still delivering value to the customer. Now that's not hot enough as a data scientist, as you see, like algorithms and latest LLMs and whatnot. But at the enterprise level, at the public level, at the lots of situations that I see in the market is, as I mentioned, because as a long tail problem. So the model bit is already there, but the ecosystem around there is not mature enough, and MLOps is targeting towards that, and I work with these kind of situations. So I hope to learn a little bit more in today's panel.
Okay, so Faisal, I love your comment about it's not hot enough, right? So, and but I mean, going back to my teaching experience, right? So many people would say, "Hey, I finished this course on plug in some online MOOC. Hey, I finished this course from that website. I finished all the course. I passed with flying colors. But when I go back to my organization, yeah, I still cannot really show impact, right? So there's a lot more than just building the model that goes on that of course most beginners, they do not understand. So let me start with perhaps maybe Faisal, you can tell us very quickly. I read it somewhere. I mean, so that 87% of the ML and AI projects, they never make it to production, right? So they got to be some challenges. And can you give us an idea what kind of challenges actually are there in operationalization or productionizing a machine learning model? And how does MLOps actually help us overcome those challenges?
All right, thank you, Raja. Maybe I'll give my 2 cents, and then my colleagues can jump in as we go. So let's understand like what is MLOps first, and then I'll give you a couple of scenarios that helps you better understand what problems it's solving. So if you know applications, right? So in 2025, 30 years ago, and yes, that's old I am, when you're building applications, you need to like package your software, then you throw it like FTP it or email it to the operations people, they install it on the virtual machines, and then security guys will do their things, and then after a few months, your software is usable. So as the time progresses, we created a thing called DevOps, where we bring on standardization. As soon as the developer checks in the code, automation picks it up. It installs the like guardrails like security and compliance and other things around that, and then automatically install the software. The APIs are being built by cloud vendors and things like Kubernetes that automates the deployment of your code that you have done. So software engineering, I would say, has been much more disciplined now as compared to 20, 25, 30 years ago. Now, when we go to machine learning, we don't have that kind of discipline into the machine learning lifecycle yet. It is more complicated than normal app development because beyond the restrictions of consistency, security, they have other things like, as Raj talks about, as data can be drift. There's a concept drift. How do you version your models? When you're retraining the model, how do you make sure it's the same data that you have trained the model the previous version? So data versioning is a problem, right? And then when you deploy the model to production, how do you make sure that model is still delivering value for the customer? So that kind of complications adds up on already solved problem for the normal application. So that standardization and that discipline MLOps tries to bring in your machine learning development lifecycle. So that was machine learning trying to solve, so that when you train a model, it's how quickly it can deliver value for the business. So that's what MLOps is all about. So one of the main challenges that I see in the market, lots of customer, is the model is working good enough on the laptop, but when it goes to we deploy to production via, for example, standardization like containerization and deploying on like clouding tools. The business says, hey, I'm not getting the values. Whatever you promised and whatever you showed me in the demo is not getting translated into real life. So we need, one of the challenge is how quickly we can iterate, how quickly we can learn, and how quickly we can iterate with that. And that is one of the bigger problem is, for example, how do we version my data to make sure that the next iteration is as good as comparison with the previous one? That's one challenge, right? How do I make sure that when I deploy the model, I own the whole, as a data scientist, I own the whole deployment lifecycle. I don't need to engage IT people. I don't want to engage app developers, because that will create slowness in the whole iteration counter, for example, right? So these are the two major challenges for me, is how fastly data scientists can iterate and how fast it can collect real world metrics and compare it to deliver value. That's two major challenges MLOps is trying to solve so that we deliver business value, and that is all done by data scientists, which generally they are not developers. That's the number one thing that I see in the market. And again, so what I feel that low code platforms, like, okay, you don't need to be a data scientist to build a model, that will diminish, I think. The tools that are enabling data scientists to be more productive will gain more popularity as we go on. So there's a couple of things here.
Yeah, thank you, Faisal. And Hamza, you founded ZenML, so definitely, I mean, you have some insights. So, can you relate to any of the challenges that Faisal pointed out? Anything that you would like to add?
Yeah, absolutely. So I think Faisal summed this up pretty well. Like when I look at the MLOps process, I try to draw a lot of parallels with DevOps, and I think that was like nicely articulated by Faisal right now, how we went from like emailing over the code to Git and through CI/CD, and like all these automations and standardizations that took place in the last 10 to 15 years. And often I think it's hard to distinguish a line between why is that not directly copy pastable to the machine learning world. And what I like to think of it as is that I like this analogy where you think of it as a system. And if you look at a traditional software system, the input that affects the output of a system is one thing, which is the code that the developer writes. And code is actually surprisingly complex, of course, but still manageable. So you can manage complexity of code bases by writing tests, by doing things like CI/CD, as we said, automating these processes. And it's also relatively constrained within systems that we understand. The code repository will be in GitHub. Maybe you make a push and the CI job runs maybe in GitHub Actions. Some tests run on PyTest, whatever. In the case of machine learning, we have that dimension as well, but there is an added complexity that there is another thing that affects the output of the system, which is the data. And if you look at the pipeline as a sort of a linear process that flows back into itself, when code goes back, it's easier to manage, and we figured that out. But when data goes back with it, it suddenly starts to become exponentially more complex. If there's any distinction between data or like DevOps and MLOps, really, it's trying to get a handle on the complexity of the data that flows back, so that these machine learning models that flow out of the data can be deployed reliably, efficiently, even automatically. I often try to think of it in the sense that if I'm in a code base, right, I have, let's say, a lot of the listeners today are data scientists, they might know Python. You have a requirements.txt file, and in the requirements.txt file, you can do pandas equal 0.25.0, right? And if pandas updates it to 1.0, nothing breaks, right? Because you have it fixed. It's frozen sort of in code. But think about it, if you feed an image to a convolutional model, or you feed a prompt to a large language model, one letter of that prompt is sort of like a requirements.txt thing, right? It's like something that should have been written in a requirements.txt, but you can't really do that. You can't just put it in there and fix it and freeze it. It's going to keep changing. And it's going to especially change once you deploy it. So just to illustrate the sort of difference between code and data. And that's
so
really...
Hamza, I mean, sorry to interject, if you allow me to, right? So can I sum it up for the audience that you're saying data is far more complex code is, because most of us would think coding is hard, but data is harder, right? So it's a bigger and much difficult challenge to handle for a real engineering organization, right? So most of us build models on Titanic .csv, right? So all of us, we start with that, right? But at the end of the day, real world data sets are not your Kaggle data sets, right? So
exactly, and I think it's additionally the complexity increases because the data lives in different systems, right? So you have to go from your databases like your data warehouse like Snowflake. You have to perhaps deploy at the end to a Kubernetes cluster and consume the same data. This whole process versus a DevOps process, which is a bit simpler, is just the key difference here.
Yeah. So it reminds me back in the day. Fresh out of college, I started at Bing, and then just a malformatted string would come in, and our entire merge job would fail, right? So you're processing terabytes of data, and something unexpected came in, and then now everyone is screaming, right? So where is my report? Where is my dashboard, right? So because the job at 3 a.m. in the morning when the data arrived, right? So we ran the job and the job failed, and what can we do, right? So great, right? So maybe I will use this as this context as a segue, and Mehdi, for you, you run or you're responsible for engineering all of it, part of it, I don't know, for Amazon Ads. And I've worked in ads in my past life as an engineer. You're literally talking about billions of listings, and you have these sub-millisecond responses that you have to give. Someone comes in, types in some query, and you have to literally run that auction in sub-millisecond, just present those ads. So any thoughts on how MLOps can help these kind of ultra large scale systems, maybe your system or in general, right? So how's MLOps helping in these scenarios?
Yeah, no, I think this is a really good question, and I agree with Faisal and Hamza on when they were talking about the challenges. Like Faisal talked about standardization. Every time I hear people talking about their system being unique or being a snowflake, there are templates that we can and patterns that we can generalize, but to the scientists who build the models, to them it look like it's unique, but to folks who do it, who have done it long enough, they can recognize the patterns behind them. When Hamza was talking about systems, I was reminded of Leslie Lamport, who's the father of distributed systems. And he said a distributed system is a system where a computer that you did not know exist can make your system fail. So, so I think understanding that we are dealing with distributed systems, and going back to the idea of like why do 80% of ML models do not reach production? If we start from the customer each time, and we ask the question, what is the customer requirement, and then work backwards from the customer requirement, because in each case, you know the latency requirements and what have you, we can understand do we need all components to be consistent? Is consistency ubiquitous, or can it be eventual consistency? Then the same question goes to latency. Can we do some, a lot of the workload can happen offline, and then we can decouple the kind of the fast twitch, fast streaming data pipeline with a much slower data pipeline. So these are the tricks that we apply in production scale systems to achieve what you're talking about, millisecond scale, but we are not really but we're not really like pushing ourselves uh, to essentially prohibitive cost. And we are so that's the tricks that we have to use in this sense. But but going back to the idea of in ML models, the biggest I'm sorry, the biggest challenge that I feel that we face is understanding of how do we build unit test, how do we build integration test, how do we build um, you know understanding of the downstream effect of our models, because once our models are running, they can cause failures in a distributed system sense. Maybe to all the younger folks who are listening, here, the message is that don't be afraid of like 80% of the product of the ML models not reaching production, because if you start with the customer and work backwards, your chances of success are much higher. And then to all the practitioners out here, I think I'll ask the question, how do we build a framework where we can do better monitoring, better baseline, better setting up a way to assess the quality and the accuracy of our models. And the Iqbal you were talking about is, if we can hit ethical or compliance or privacy challenges, how do we do it in a privacy compliant way? So those are kind of the bigger, broader questions.
So what are some of the issues that typical machine learning engineers, call them data scientists, machine learning engineers, just give them any name, typically they would overlook, that might have very serious implications down the road for the company, right? Any sort of implications. And perhaps you can just give an idea, like how would MLOps help us? Issues that are not technically engineering issues, yet could be avoided if you have a good, solid MLOps infrastructure.
Yeah, Raja, that's a great point. And I like how the discussion evolved. I like what Faisal was doing about, the distinction about the development and then the deployment. And then Hamza also made a great point about, hey, it's not only CI/CD, there's the data, there's the model to deploy, right? If you recall our workshop we did here at Data Science Dojo, we said the AI/ML with Kubernetes. Two of the bottlenecks usually are the data collection and the model deployment. So coming back to what Faisal said before, I think there are two development phases. One is called the inner loop, where developers code, test, create an artifact, right? And if you think about the data scientists, it's the same thing. They develop the model, they test the model, and then some automation, like Amsa was saying, some CI/CD can build this model as an artifact, can be usually a container image, right? If we target for Kubernetes, which is most of the time our target platform. So we connect this development phase called the inner loop to a deployment phase called the outer loop. And this connection is awfully automated, right? And it's going to be like if you look at the DevOps logo, it's usually an infinite loop, right? Because you start from the coding, then you deploy, and then you're coming back to update the model, and then you're coming back to deploy it again. So as we discussed, one of the bottleneck could be really the data collection, the model deployment. And I think the DevOps evolution in that, called now MLOps, can really help with some of the automation, like, hey, the data can be retrieved from a bucket automatically and could be fulfilled, and then the model can be containerized in a container image representing this model, right? And then some CI/CD process can deploy. And I want to make a point here also, which the evolution of DevOps right now is also having a GitOps approach. GitOps is a methodology. I think it's a kind of evolution infrastructure as a code where everything is on Git and everything is managed as a Git workflow. And we can, from the deployment phase of the model, this can be really helpful because it makes sure, again, consistency against multiple deployment of this model in multiple environments. Faisal mentioned the edge, right? If you have multiple devices, even at the edge, how can you make consistency? How can you make sure that the data science can change something and this change can be deployed in multiple phases and maybe can be rolled back? I think GitOps is also helping DevOps and now MLOps and ML engineers on that. And to facing those changes about the model deployment, right? And to your point, Raja, what are the other challenges or consideration? Well, I think security has a big spot here, right? You mentioned it also, Faisal, security, because we're deploying this everywhere to you as a public transportation user. We're deploying this to users, and we need to make sure that this is a secure process, and this lands also in the automation of a secure process. I need to make sure this container image representing the model, it's made in a secure way. I need to control the layer doing this. I need to control and the code quality of the model, right? When I write the model, it should be automated, right? And then I make sure that this deployment is secure and it made secure and scan the container image deployed in some environment in a secure way. So I think the industry now is putting more focus on security in this part of the automation, and also MLOps communities are taking benefit of this approach.
Okay, thank you, Natalia. So perhaps another follow-up question. So the discussion is flowing very well here. So call it horror stories, call it real issue, right? So all of us have older people, right? So all of us have our fair share of those stories. Anyone wants to share any interesting story, and at the end you said, oh wow, such a small issue resulted in such a big problem, could have been avoided with better process, right? So at the end of the day, MLOps is, well, formalizing a process and deployment practices and end-to-end practice. So anyone wants to share any stories?
Sure, I can go first. So this was back at Microsoft, and we were running a system that was really the customer adoption um, was pretty moderate. Like we were not hitting a big scale, but still we were having frequent shutdowns of the entire system. So it was scary because the customers that we did have, there was a chance that we would lose them. Um, after so what we realized was happening was that in the entire system, we were managing state by message passing, and the message passing was becoming so chatty that it was itself bringing the entire system down. And it was like we had like two different systems talking to each other, and the snat would essentially cause all the IP ranges to be exhausted. So you would end up like not having any way, like, so we were essentially isolating the components without realizing it. And it's such a simple thing. And once we realized, I actually coded one line of code to fix it. But it took at least I would say uh, 3 days, 3 nights, with a lot of the ops engineers working around the clock to figure out what was the actual root cause.
Yeah. I also have some which is closely related to what Faisal was saying. So we were in the previous startup I mentioned we were doing predictive maintenance, and like Faisal was saying, like we were also working with like public transport, specifically buses. We had a fleet of 700 buses we had our systems in, and like we definitely had the COVID problem. I think everybody working in predictive maintenance in public transport had the concept drift of COVID happen. So we had to sort of retrain the models. But one small one, which is also an example of concept drift, is they ended up taking 10, like it was winter in Munich, and they ended up taking 10. I don't know. It was a component in the bus. Maybe it was doors, and they changed that. And suddenly we thought that okay, we have 10 buses which are broken, and we were like pinging alerts, and it turned out that they checked and everything's fine. What are you talking about? So we had to really go back to the workshop. We had to understand what happened. It took a while, and it could have easily been avoided if we had some sort of concept or model drift detection in place that could have told us, hey, the concept drifted underneath us before we like ran the predictions. So that was a really cool, a bit harsh, but a cool lesson to learn in the out there.
And the coolest lessons are also the harshest lessons, right? So that's how you learn, actually, right? So yeah. So this is great, right? So I'm more on the science side. I don't know much about data engineering, right? So So concept drift is a problem, right? So I have heard this a few times. I think all of you mentioned it at different points, right? So do these tools, MLOps tools, do they have some built-in mechanism to tell you, hey, the data is shifting, or the distribution of data is shifting? Can anyone elaborate on this? Anyone educate us on that?
Yeah, maybe I can take a shot at that, and maybe guys can add it later. Is as we already know now, what we're saying, the normal difference between DevOps and MLOps is additional dimension of data, which add the complexity, and we have to deal with data versioning, and we have to deal with what kind of model performance that we're getting in real world. So one way we were doing that at one of the customer is we have some automated tools that that captures, for example, when the model predicts, it gives you that confidence level of how confident it's on its prediction. So what we did is the MLOps tools helps you capture those confidence level, and then we have automated reports that see the drift in that confidence level, how it's going down or it's going up, for example. And that helps us see that there is some sort of drift is happening. It could be because of concept or data, but the model is not as useful as it used to be. So MLOps tool can give you those kind of charting from open source perspective at the tools I work with. But I don't know of any tool that can magically give you a take, hey man, just go and you have a concept drift and do your thing again, right? I don't think so there exists yet, maybe at the research level, but in the enterprise, or what I said, the real world scenarios, is we can collect the data, we can see the pattern that's happening in production with the model automatically, and based on that we can bring on the alerts that can trigger some retraining or some remediation effect, right? And that's what I was talking about originally, is the tools are there to enable the SMEs, which are the data scientists and data engineers, to do their thing faster, and that's the job of MLOps, in my opinion. So that's my 2 cents.
Yeah, Faisal. So you mentioned there's no such tool. Maybe, I mean, a new startup idea, right? So both of us can get together, because
Yeah.
this is a question that is asked so much. And really, concept drift is one of the, I would say, one of the biggest challenges, right? So your data keeps changing. Your representation of what you're trying to, predict or get insights out of, it keeps changing. So how do you actually detect it early? There can be some heuristics, but if maybe there are some tools out there, I'm not familiar, but that's why I was asking, right? So because the ecosystem is so big, someone may know something that probably is emerging out there. So let's. Anyone else wants to add anything? I mean, I don't want to.
I think
thing,
right? I just want to mention a few. So there's like deep checks. So we have great expectations. We have evidently, there are tools, Aporia, like there are many tools that actually tackle the problem. But I think the core thing that Faisal was alluding to, which I think is really key here, is the tools are just, the tools are great and are really helpful. But concept drift is actually quite hard to detect just fundamentally, because it depends on the problem, and it also depends if you're doing images or text or just tabular data. And I think, if anything, what we're doing in MLOps and the whole ecosystem, the way it's developing, is we are a bit like ChatGPT. We are giving assistance to people who actually know what they're talking about and doing, to actually figure out those problems. So if anything, it's more of bringing things closer to the data scientist, the ML engineer, so they can call the shots. But that last gap is still sometimes a human thing, and can be semi-automated for now, but I think it's quite hard to fully automate in all instances.
Mm-hmm. Okay.
And Raja, if I can to this point, I think there are lots of tools, no? But as was discussed, there's no one tool that makes everything out of the box, right? It's like a toolkit. You have to build your own framework, right, on top of a common platform. That's why I think it's important having kind of a reference architecture, blueprint, or something you can follow. And this is the approach of an open source project that Red Hat is it's pushing, which is Open Data Hub. It's a sum of tools, existing tool combined, where you can use as a toolkit as a starting point. So because there are, there's the models, the deployment, and there are the observability. To your point, Raja, we need more observability. It's not gonna do the thing you asked, right? But you have the toolkit to build on top. And so it's important to have such reference validated architecture or validated pattern, in my opinion.
Okay, thank you for your insights, Natalia. So maybe I will ask you the next question, right? So I find open source to be, I don't know, as a technologist, one of the best things that has happened to humanity, right? So I mean, you just go and get that open source project, and things move really faster. So how has in general, Natalia, in your opinion, right, how's open source enabling? Hamza mentioned that ZenML is open source as well. So how's in general open source enabling organizations to accelerate this whole adoption? And you work for Red Hat, so how's Red Hat actually involved in any of those initiatives?
Yeah, thanks for this question, Raja, because really Red Hat core is open source, right? Like the why of Red Hat is open source. Like, and the first thing you think about when you think about Red Hat is open source, and it's an open source in everything, like also in this space. Let me also tell you that in general, the science is open, and also tools that data scientists are using were historically always open, right? But right now there's a kind of like explosion of tools because it's easier to write models, it's easier to deploy them thanks to this offering. And I think what Red Hat is trying to do, and it's keep pushing this momentum of open source also for machine learning, artificial intelligence, and data science, providing again guidance, providing architecture, and like for Open Data Hub, which is an open source project, providing ongoing kind of distribution for machine learning operation. Then on top, Red Hat also build products, right? Red Hat OpenShift Data Science is the product behind the Open Data Hub. But still, all the innovation, it's in open source. This is something that Red Hat really believes in any product that it does. And moreover, in this space, again, which in data science, which open source is really it's really the accelerator. And you see the startup like ZenML or other startup, they have their own open source toolkit, and they build a product on top, right? So I think it's a winning model that will help communities going into the space and evolving the technology.
Thank you, Natalia. And so maybe expanding on this a little bit, looking at the entire ecosystem, right? So how are other tools, let's say Docker and Kubernetes, and the whole idea behind this orchestration using some of these technologies? So maybe Faisal, I know you are an author on this topic. So you and Hamza, I mean, both of you, right? So any thoughts on how can they be helpful in setting up or maybe enable organizations in being
so
better at MLOps?
So maybe I'll start, Hamza, if you don't mind, and then you can continue. Okay, thanks. So I'll continue what Natalia was mentioning. The open source, the beauty of open source is basically to reduce friction for adopting technology. Like, again, because we're old people, if you like in 2000, if you want to do something with databases, you have to buy licenses for IBM DB2, and nobody has the money to buy licenses for IBM DB2, right? So what open source enables people is they can download the software freely and work with that, so that it enables people to innovate more. That's for the software part. And when the cloud comes in, it actually tackles the hardware part. You don't need to buy AIX machines or E10K boxes from Sun Microsystems to see how your software can work at scale. So clouds give you that capability, reduces the friction to adopt the technology. So what Kubernetes and the relative ecosystem that's bringing it, actually going one level up, is simplifying and standardization of the technology to adopt. It is open source, so you can download it, you can play with it, you can build on top of it. but actually bring on standardization. One example I give you as a data scientist, a few of my team members build something on their laptop with different libraries, like Python libraries, the C libraries that comes with it, the GCC libraries if you're coming from Linux background. But if you're not using containerization, if you deploy it, there may be a library clash. Maybe one model built on 3.9, maybe one model used 3.7 for example, Python, and that creates, that reduces the velocity of the team to deliver value for the business. So what Kubernetes brings is give you that standardization options. So as an architect, we sell options, and the SMEs, the data scientists, select the right options as they go by, right? So that Kubernetes bring on standardization of technology. So you go in containers to have a consistent and reliable deployment, for example, and then you build tools based on those standardization. For example, if you want to deploy your data versioning solution, again, the container is the way to basically package it and deploy it. So you don't need to worry about managing that data versioning system as separately. Or if you want to deploy a machine learning drift system, or as Zen was talking about, let's say great expectations, you want to write your Spark jobs to process your data. Again, you do not need to worry about how you run those jobs and how those jobs will scale as your systems goes beyond development and test environments. So that standardization that Kubernetes bring will enable you to focus on the things that value for the business, and let the tools, the abstraction layer, taking care of scale, consistency, security, and a few other things that Ali mentioned. That that abstractness that Kubernetes bring for you to keep your focus on business value while using different tool set of different natures. That's one key thing that Kubernetes bring for the organizations.
Yeah, this is exactly right. I think in the context of MLOps, the transition from the inner loop, as Natalia was saying, to the outer loop is largely today facilitated in many organizations through containerization and Kubernetes, because it's a standardization layer that lets you feed applications on top. Now, I think one of the interesting questions that pops up out of that is that, does that mean, I think we had a question also in the chat, does that mean that the data scientist needs to know all about Kubernetes and containerization to be able to own that process? And this is where MLOps tooling is very interesting. So like we mentioned now, Open Data Hub, like with ZenML as well, we're doing the same. So like ZenML is a layer on top, which sits on top of things like Kubernetes and also other MLOps tools. And then you can pick and choose machine learning tools like Great Expectations or any training libraries and deployment libraries like MLflow or experiment tracking. And through the interface of ZenML with this abstraction, you can then deploy these workloads starting locally and then going on into containerization. And largely that is facilitated by Kubernetes. So I think a lot of MLOps tooling, including ours, what we're trying to do is really abstract things in a simple enough way that the data scientists can really understand, like it's close to their native environment, which sometimes it's in notebooks, sometimes it's in scripts, and understand the basic setup. But then it's a sort of a one click or one switch process for them to get to those other systems. And if we are able to, abstract the Kubernetes and the infrastructure layer away from the data scientists, I think that really almost like commoditizes MLOps. Also it brings a huge amount of value. Just like Kubernetes abstracted away the machine layer, that like the metal layer from a lot of DevOps engineers from the, we can also abstract and let the data scientists own production in a more efficient manner if we are able to abstract away in a smart way the complexity from MLOps systems so that they can own their pipelines in production.
Okay. Thank you, Hamza. I believe we have some questions. I'm asking my team to actually send me those questions. So just on a lighter note, Hamza, you mentioned Great Expectations, right? So, and then we have Kafka. I mean, comes up with these names? I mean, these are all literary references, right? So, I mean, there must be some English literature majors, I mean, naming all of these things, right? So,
I don't know, like we named it ZenML, so I'm not one to talk. I'm not one to talk.
Yes, yeah. Okay, so please go ahead. I think someone wanted to ask something.
Yeah, so I just want to have a funny story on that, because on the namings, I went to a marketing seminar, and then we were using a integration platform called Apache Camel. So I was confusing in that, and then the competition said the competition name was Mule. So this naming, we are not great in that, because we have Mule, we have Camel, and they have some philosophical reasons behind there. But I think they just we just don't
blame
waste
O'Reilly
time.
for that, right? So O'Reilly, I mean, so the snakes and birds and all of that, right? So
Yeah, exactly.
Yeah. Okay, so let me start taking some of the questions. I'm actually trying to filter. I mean, there was a classic Python R C++ question. I'm not going to answer that, right? So I mean, maybe we can handle that on the forum. But then there is a question. Maybe it has come up at the same question. How can version control be used in MLOps, and what are some best practices?
There are two dimensions of your machine learning lifecycle, as we talked about. One is the model itself, and the other one is data. So it's very important to, when you version this, you have some correlation between, for example, if you train a model against a particular version of data, and then you version your model. So when you do a retraining in the model, you can see the benefits you are getting in your algorithm tuning, like hyperparameters, for example, while keeping the data consistent. Or next time you have new data, you can see how the new data is having your is impacting your model performance. So the way one way of doing model versioning is if you just containerize your model, and then you just have a version of your containers in a container registry. That's one way of doing that. The other way of versioning model is there are different tools, like one of the tools that is open source by Databricks is which calculate the different versions of the model itself. So you have your for example model in HP format, or you have the pickle model that will be stored in a registry, and then you can version there. So that's two dimensions of modeling the version model itself. The other is the versioning of data. So tool like Pachyderm, for example, they give you a Git-like structure, or DBT. They give you a Git-like flow in which you have the metadata of your data, and then you version against that. So there are two ways of doing that, two dimensions. And there are tools like Pachyderm, as I mentioned, that's available for versioning your data, and then you can version your model as a container itself. Yeah, so this maybe two cents.
Okay, thank you, Faisal. There is another question, right? So it is an interesting question, actually, very interesting question. What if my company actually refuses to adopt open source?
So I think, in my opinion, a lot of companies says, hey, we don't want to use open source. And when we work with them, we found out they are using open source anyways. They have some deep library in their Spring framework, for example. They're using some Java runtimes. They're using Linux. They're using all kind of open source solutions like TensorFlow, for example. They're using it, and they didn't know that they are using open source. So the question to me is, we have to reframe the question is, there's a disconnect between people who are responsible for the security of that organizations and what is happening at the engine room, or where the code has, or things have been developed. So what, in my experience, is when we connect with them, oh, we are already using it. So that's one way to showcasing them they're already using it, and you can put guardrails around that. One of the guardrails is, for example, you can have a proof list of software that can be come through your supply chain. That's number one. The other guardrail is you can buy support from vendors like Red Hat for your open source solutions, to pay some dollars to them, so that make sure that the security patches are delivered to in a reliable fashion. So both options are available.
For the uninformed, right? So if I hear you correctly, organizations, the only concern, they appreciate open source, they like open source, but typically the concern is around, it's more around security. Is that correct? Or are there any other concerns that they have?
So the other concerns about open source, I don't know if you guys remember, there was a guy who written a JavaScript library that takes the padding from a string, LPAD and RPAD. And one day he deleted his Git system, and lots of toolings, like for example AWS CLI, broken because they are using the dependency on that open source. So other consideration the organization I see is the dependency on that on that community. What if that community decide not to do anything tomorrow? What will happen then, right? So that is our other problem that we see in the open source. And of course, organization which sell you enterprise support can be a one solution. The other solution, you build that capability to clone that Git repo and maintain your own. So these are the multiple options available, but that's the other dimension.
Yeah,
And Hamza, I'm assuming, go ahead, please. And,
no, sorry, just to close this, I think it's important also, as you mentioned, Faisal, to make being an active contributor if possible, right? Give back to the open source. You're using open source. You wanna, but if you don't want to go to that path, also try to give back to open source. Try to be involved, because the process is, again, or you contribute, or you have some kind of enterprise support where you are guaranteed that certain version works all the time. So I think it's a trade-off about that.
Okay.
Thank you.
Thank you, Natalia. I absolutely enjoyed the discussion. It was a very good discussion. I think that the time was not enough. So thank you so much, all of you.
Thank you very much for the invite.
Thanks everybody.
A pleasure. Bye.
Thank you.